You know.
Okay, I said when I was trying to do my assignment, when I was trying to finish up, I was having kernel issues. It was telling me dead kernel, and I don't know what dead kernel is.
Dead kernel.
Yes, I tried reconnecting because I went to the kernel option. I saw reconnect, then I tried reconnecting. It was showing me can't connect or something. It was just giving me a lot of issues.
You should have just done
Then
restart
I
kernel.
was now trying to if I make all my progress to be lost.
Hello.
Hello, I can hear you, please.
I said you should have just restarted your kernel. Then you rerun the ones you've run.
No, if I had restarted the kernel, it told me if I would restart it that it was going to make all my progress to be lost,
No,
and I
it's
didn't
not
want
like
that
your
to happen.
it's not like your progress will be lost. What will happen is that your what I put it now. Everything you've run before, you have to rerun them.
Oh, but the input will be there.
The codes you've written will be there.
Oh, okay. So I was having that issue, but then I was like, if I can just upload this in and send it to you, maybe if you see it, then you might if I explain to you, then you might be able to understand better. I could not import my I couldn't import the file into my repo on GitHub because I'm just new to GitHub, so I don't really know how to use GitHub.
Yeah, I was going to show you guys how to use GitHub today, but then I
So
don't know
that's the
why
second
everyone else.
issue I had.
Okay, welcome, Ibukun. So okay, let's wait for others for the next 5 minutes. Then if we don't see them, we'll just continue. Any problem with the assignment, Ibukun? Saying Ibukun is sounding weird in my mouth. Oh, I've not compiled it to one. Okay, we are now 4. Okay, when it's I said 10 minutes that time, so when it's 15 minutes past 4, we'll start. So we can have others. Probably we are just getting home. It's the weekend already. So people might have to branch some places. Ah, wow. There's no rain here. So let's just wait for them for the next 5 minutes. If there's any questions so far like, about the assignment, why you did not submit and the likes, you can ask them now. Because the first thing we'll do in today's class is we'll do solution to the last assignment. Then we'll enter today's class. Then we give the assignment for today's class. So any questions so far? What's the actual problem with installing Aconda app, abeg? What's the problem you face installing Anaconda app? Samuel Joshua, what's the problem you face installing Anaconda app?
I've installed it. I found the way and installed it. I've installed it.
Okay. So you will submit your assignment before the end of the year, abi? So I'm expecting everybody's assignment before end of day, even though I will do the solution in class today. Just try and do the assignment. Try and follow what I did in class and solve the problems in the assignment. Don't say because I've done it in class that you won't do it again. We learn programming by repeating things, like repeating things we've done over and over again. It's not like repeating, but then you have new challenges that you face. So you have to think of new ways of solving problems. So please let's try and do the assignment, I beg. So in the next 2 minutes, we'll start today's class. So I'll basically show us how to use drag and drop on GitHub then how to use drag and drop on GitHub, then the solution to our assignments. Then we'll now start Numpy, data analysis with Numpy for today's class. No, I know you said you could not do it before deadline. You can still submit after today's class. Okay. I think it's a good place to start now. So everybody, welcome to today's class. How was our day? Hello, I said, how was our day? Oh?
It was fine, sir.
Okay. So let me do this crash course. I mean, the solution to our class from last class. Then we push it to GitHub together. Though I'll use drag and drop, I won't use command line interface. I believe with drag and drop is easy for everybody to use. So I'll use drag and drop that we'll all understand. So basically, the last assignment. So this is an optional exercise. So it's not like everybody must do it, but then can do it. So the first question: what is 7 to the power of 4? So I believe everybody should be able to do this one. Then split string this. So how do you split it? Just do dot split. No, we split it by space. So you split by space from there. Then we said format string. So I believe I shouldn't be reading what I have on my screen. I should just be scrolling. Then if there's anyone that probably when you were doing it gave you a problem, or there's anyone you don't understand, just stop me there so I can explain better. So I won't spend too much time on this assignment. No, we are not saying anything. It means we understand everything. Since we understand everything, so I'll push it to GitHub now, so I'll understand how to push to GitHub. But then my GitHub account is open on my Chrome. So I'll move back to, okay, this is my GitHub account here now. So I was checking someone's assignment. Who is Adeyemi Favor? Is the person on this call? Adeyemi Favor. Adeyemi Favor is on this call, but then Adeyemi Favor is the only person that submitted the assignment. So this Adeyemi Favor's assignment. That's what I was checking earlier today, and she did a pretty good work. At least she was able to do most of the things that was expected of her. even though our methods are different from my own method, but then she was able to get everything done. So a big shout out to Adeyemi Favor. So let me just go back to my GitHub homepage. So wait, I'm not signed in. Okay, am I signed in on my? Okay, let me check GitHub. Okay, here it is. So undergraduate IT class, this front-end class. Okay, this is the IT and the data science stream. So here the codes I've pushed before, but then I would have loved to create a new repo, but then I don't have anything to push this evening. So what you do normally is you come to the repository here, then you request new, then you give your repository a name, you can give it a description, then you create a repository. Are you getting it?
Yes, sir. Yes, sir.
Okay. When you type the name of the repository, if the name already exists before, it will tell you you can't use that name. But then, for example, I say ASUU IT class. You can see it's putting mark there that this thing is available. But then if it's something that is not available, you tell me no, it's not available. So you give it a description, you make it public so that anybody can access it, and create a repository. But then if it's a work that you don't want anybody to see, you make it private. Then just press create repository. So it will create a repository for you. So when you create a repository for you, what we have here will be blank. There won't be anything here, but then to show you a page like this, then you can press sorry, let me go back. So you see something written for you, then you can click on what's it called now? You click on add file. So it will write some things on your screen for you. So all these ones won't be there yet. So this one will be bigger than this. So it will now write some things inside. Then you can click on the add file on this thing. Then you click on upload file. So you see upload file, you can see it said drag and drop file here, or you choose file from this thing. So if you press this, it will help you to navigate on your system. But then if you don't press that, you can easily come back to your system and navigate there. But then I can easily just press this. I didn't even have opened the folder before. It would have been easier for me. I would just have drag and drop. But then here is the folder. So Python crash course. So the file I want to upload is solution. So you can see it's automatically uploading. So if I want to upload more, I can just come back here. So let me just upload the material for today's class automatically like that. So data analysis with Numpy. So I'm going to Numpy like that. So I have Numpy array, exercise, this, then operation. So I'm uploading all this. You can see it's uploading the 4 files I selected now. Then you give your commit. So you can call it first commit, but my own is Numpy class. So I committed this one for Numpy class. Then if I click on commit, it automatically commit it to my system. You can see it was 2 files that were there before, but then it should have turned to like 8 now. You can see 1, 2, 3, 4, 5, 6, 7. Okay, 7. It can turn to 7 files. You can see day 1, and that's 3 days ago. But then I uploaded these ones now. So you can see the commit this thing now. Day 1, then Numpy class, and it's now. So by the time I'm uploading here, next time it will tell me on the number of times that, okay, tell me the number of times that I've uploaded. You can see 29 seconds ago. So that's that on that. We've done Python crash course now. So I can close this tab. I can close the GitHub tab. We all understand how to upload our code to GitHub now.
Yes, sir. You understand?
Okay. Is there anybody on this code that doesn't understand how we upload our code to GitHub? Anybody? Anybody?
No, sir.
Okay. Since everybody understands, so let's. Okay, let's go on. So let's come to NumPy now. So NumPy is a linear algebra library for Python. The reason it is so important to data science with Python is that almost all the libraries in the PyData ecosystem rely on NumPy as one of their main building blocks. So basically something like numbers and mathematics. Mathematics is built on numbers. So most of the libraries I will use in the entirety of this course are built on NumPy. So that's why NumPy is very important, and that's why it's the first library we normally treat when we are doing data science. So NumPy is also incredibly fast, as it has binding to C library. For more info on why you would want to use array instead of list, check out the great Stack Overflow. So the reason why you will use this thing, what's it called? Array instead of list. We've done list before. We've done list when we're doing Python, but then it's better to use array over list. If you click on this link here, it take you to what are the advantages of using NumPy over regular Python list. So you can read what we have here. NumPy array are more compact than Python lists, as a list is of lists as you describe in Python will take at least 20 megabytes. So while NumPy 3D array with single precision float in the cell will fit into 4 megabytes. You can see what list will take to 20 megabytes, NumPy will take it to 4 megabytes, meaning it will reduce the size by a ratio of 1/5. Access in reading and writing item is also faster with NumPy. Maybe you don't care that much for just a million cells, but now definitely you would be, but you definitely would be, you would for a billion cells. Neither approach would fit in a 32-bit architecture, but with 64-bit building NumPy would get away with 4 gig or so. Python alone will need at least 12 gig. Lots of pointers would double in size, as much as costlier piece of hardware. So what this is just telling in essence is NumPy reduces the load of work your system will need to do, depending on size of file, compared to using compared to using lists. So that's basically what that one is explaining. So moving on from there, we will only learn the basics of NumPy. To get started, we need to install it, but then you don't need to install NumPy again, as NumPy automatically comes with the latest edition of Anaconda, because it's what majorly everybody uses NumPy these days. So they just ship it with Anaconda for most people. So that's NumPy. So we are importing NumPy as NP now. So NumPy has many built-in functions and capabilities. We won't cover them all. Instead, we will focus on some of the most important aspects of NumPy: vector, array, matrix, number generation. Let's start by discussing array. So NumPy array. Array are the main ways we use NumPy throughout this course. NumPy array essentially comes in 2 flavors: vector and matrix. Vectors are 1D array, while matrix are 2D. But you should note, matrix can still have only 1 row and 1 column. I believe people with or 1 column, sorry. People that did vector in school, we understand that matrix is just a collection of vectors. So then, even if you have just 1 vector, you can look at it as a matrix. So you can say matrix of maybe 3 by 1 instead of 3 by 3 or 3 by 2. You can say matrix of 3 by 1, something like that. So moving on from there. So here is a list now. We created a list. We called it my list 1, 2, 3. So we created this list. How many of us remember list? How many of us remember list from the last class? So
I remember, sir.
okay. Please, when I ask questions, please let's talk, because it will look like I'm just talking to myself, and it's not like I'm recording a video.
Okay, sir.
Now, so let's talk whenever I ask questions. So we are converting that list to an array now. So here is the array. So you can see it's not like you just put list inside bracket and put array behind it. But then that one has done a lot of work behind the scenes. So here is under list. So here is a list of lists. Then we'll convert it into a matrix. That's a NumPy matrix. You can see the way list wrote its own. You can see the way NumPy arranged its own. So NumPy understands now I'm working with a matrix, not just a list. So built-in methods. So we have some built-in methods for array. So here is arrange. So we can arrange the way we have range in. How many of us remember range in normal Python that we did in the last class? Do you remember range?
I remember, sir.
So what would this one do and what would this one do using the knowledge of range? What would this one give us and what would this one give us using the knowledge
The
of
first-
range now?
The first one will
First
give
one.
us, let me say, like 9. So it ranges from 0 to 10. Hello?
I'm listening to you.
Okay, I said that first one, it means that, okay, it means that it will start counting numbers from 0 to 10. Also, I don't know if I get it.
Go on with the second one.
So for this second one now, I can't even remember.
Okay. Any other person?
The second one will start from 0, but the difference between each element will be 2.
Okay. But then, is there any contrary opinion?
The number just before 11, but the difference between that number and 11 will be 2.
Okay. What about the first one too? Arrange 0 to 10.
It will start from 0 and end just before and end on 9.
Okay, that's exactly what I need to hear. So that's correct. That's correct. So I see we can still remember what we did in the last class. So you can see this, then you can see this. Is there anybody that doesn't understand how this came to be? You know, it's still the understanding of range that we are using. It's just we put np.a range. Yeah, so it sounds like array range. You get it? Array range, np.array range. That's what we did here. So I don't know if there's any question about what we just did here now. Any question whatsoever?
I think you let me to explain that second one. That one that has 3 numbers, 0, 11, and 2.
Okay.
So,
Basically, anytime we have 3 numbers like this, it means start from the first number, end at the second number, then the common difference will be the third number. So here now start from 0, end at 11, but then the common difference will be 2. So it will be 0, 2, 4, 6, 8, 10. You know, it won't pick the last number. So it stops at 10. Do you get it now?
okay.
Okay. Moving on from there, then we have zeros and ones. So to generate zeros and generate ones, people that actually did mathematics or studied mathematics, we appreciate this because there are sometimes you just need an empty matrix to work with. So here, we generated a vector of zeros. We generated 3 zeros. So the number of zeros we are going to generate will be the number indicated in here. So here now we have 5 by 5. So we have 5 by 5 zeros. You can see them here. Then we have ones too. 3 ones and 3 by 3 ones here. So whichever thing you want to generate, you can just put them inside the bracket like this. Do we all understand this?
Yes.
Okay, moving on from there. Then we have linked space. So this one will return evenly spaced number with specific interval. So we have 0, 10. So that's 0 to 10. Then the number of variables, you know, in arrange, we say the third number is the common difference. But here, the third number is the number of variables you want. So here, from 0 to 10, give me 3 numbers. But then the 3 numbers must be evenly spaced. So if you see this now, you see 0, 5, 10. You see, you pick the last number, I pick 10 here. But this one, you don't pick the last number for the arrange. You don't pick the last number, but yeah, you pick the last number. But then it's a request for just 3 numbers. So it has, because we have common difference, equal the common difference. So it is 0, 5, 10. So that's 5 is the common difference. And giving us 3 numbers. But here, we are printing out 50 numbers. You can see the common difference is 0.20408163. So if you add if you add this to this now, it will give you this, then this to this will give you this to this will give you this, like that. So we count number of numbers that are here to give you exactly 50 numbers. Are we getting it?
I have a question, please.
Go ahead.
What if the number you have there is an odd number for that 0, 10, and 3? What if it is 0, 11, and 3?
0, 11, and 3. To still give you common difference, I mean, okay, let's add a cell here so that you see what I'm saying. What am I doing? What is on doing?
Sorry,
So
I didn't get explain.
So if you see this, I'm coming. I will respond to you. Let me answer this question first. So you can see 0, 11, and 3. Abi? You're going to give you common is exact common difference. So the common difference is 5.5.
Oh, it doesn't have to be a whole number.
It doesn't. You can see here. There's no whole number here now. If you see, putting decimal place in front of everything, so the number is generated to be float.
Oh, okay. Thank you.
So the second person that was asking a question, can I have you now?
No, like I didn't understand what you were explaining.
Do you understand now?
No, sir. Not yet.
Okay. I said line space. That's what line space. Line space is just going to give you start from this number, end at this number, and give me this number of variables equal distance between this range. For example, here we said 3 numbers. So start from 0, end at 10. Then give me numbers between 3 numbers between 0 and 10. So it give you 0, 5, 10. But here we said 0, 11, 3. So it will give you 3 numbers between 0 and 11. But then there must be common difference. That is, the distance between each of those numbers must be equal. So that's why we have 0, 5.5, 11. Then here we said 0, 5, 50. So generate 50 numbers between 0 and 10 with equal common difference. That's why I give us all these numbers here. Do you get it now?
Yes, sir.
Okay. Any about person with any question? Okay, nobody. Okay, moving on from there. Then to generate identity matrix now. Why did I put my number here? I beg. And I've uploaded it online. Okay. Okay, identity matrix. So here, this is how we generate identity matrix. So if you want a 5 by 5 identity matrix, how many of us understand what I mean by identity matrix? Who can define an identity matrix for me? Identity matrix. So who can define an identity matrix? Who can define an identity matrix? This is all we fight to. Okay, someone's already putting it. Okay. Matrix with 1 in the diagonal, I guess. Hey, I'll not see anything. I'll call Dr. Lion. I'll not see anything. No. Okay. What identity matrix is a matrix with 1 in the main diagonal and 0 in other positions in the matrix. So if I run this now, you can see I have 5. Sorry, if I run this, why is it not run? You can see that's 1 in the main diagonal and 0 in other positions of the matrix. So we say 3 now to give you a 3 by 3 matrix with 1 in the main diagonal. Do we get it?
Yes, sir.
Okay, moving on from there, then random. So Numpy also has lots of ways to create random number array. So what I mean by you know, how many of us know anything about simple random sampling? Okay, let me explain sampling to us before I explain random. Okay, sampling is just basically a way in which you pick a representation of the whole population. Okay, for example, let me say, okay, for example, if you want to go and buy ice cream, for example, I don't know if you've been to those ice cream spots where you can taste the ice cream that they are selling. So now, if you go to such places, you won't taste the whole ice cream in the bucket, but then they will just give you a sample. Okay, this is the vanilla flavor, maybe a scoop. Then you taste. Okay, this is the chocolate flavor. Okay, this is the blueberry flavor, like that. You know, you tasted just a little bit of it, but then you have the knowledge of how the whole thing tastes. So that's sampling. For example, let's say we want to check for how intelligent people in this class are. We can't check everybody, for example, if we are too much. So we can just pick randomly among us. So pick randomly everywhere. They will say, okay, let's now check these people. So that's sampling. So here now we say random. So random is just to generate random numbers. So then we are now generate random number in rand. So it's something like we're entering random numbers from uniform distribution. And uniform distribution is always generated between 0 and 1. So how do I explain uniform distribution now? Uniform distribution is the distribution with a flat curve. Let me just Google it for us so that we understand. So uniform distribution. Uniform distribution. Okay, continuous uniform is a probability theory and statistics. In probability theory and continuous distribution or regular distribution is a family of symmetric distribution. What do you mean by symmetric distribution? Let me just show you. Data science is actually on mathematics and statistics. So this is a plot of uniform distribution. So symmetric in that everything has almost same statistics. That's what they mean by uniform distribution. Do we get it? Do we get uniform?
Sir.
Okay. So here is data generated from uniform distribution. You can see generates two numbers, and you can see numbers are between 0 and 1. Then 5 by 5. So you can see here is another uniform distribution generated between 0 and 1. So do we get it? Then here we are generating another set of numbers, but this is rand n. No, this one is rand. That's why it's uniform. But then this is rand n. So that's normal distribution. So what do I mean by normal distribution? Let me Google that one too, so that we can see normal distribution. We call it normal distribution or Gaussian distribution. Normal distribution. So what is normal distribution? Normal distribution is also known as Gaussian distribution, as I said. It's a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. So what do I mean by normal distribution? Now let me open a graph of it for us so that we understand. So this is what normal distribution looks like. You can see data around the mean. This is the mean. The mean is the center of this thing. You can see data around the mean are more. Okay, how do I explain this? Okay, let's check. Let's use human height. Human height is normal. It's normal distributed. That is, people that are short are not much. People that are very tall are not much. But people with average height are very much. Do we get it?
Yes, sir.
So that's normal distribution. So wealth is supposed to be normal, but then in Nigeria, wealth is not normal. Because people that are rich are extremely rich, and people that are poor are very much that they are poor. But then wealth is supposed to be normal. Weight is normal. That is, people that have light weight are very small. People that have very big weight are very small. But then people that have average weight are very high. That's the extension of normal distribution now. So here is we are generating random numbers from normal distribution. No, it's generating two numbers here, but then here we're generating 5 by 5. You can see normal can be more than 1 and it can be less than 1, and it can be less than 0. You can see -2, you can see 1, and the likes like that. So that's normal distribution. Then we can check for the data type. You can see the number inside it is float. Someone was asking the other time, like decimal place. You can see that's what we are saying here, float. If you remember what I explained in the last class about float numbers, then here we are generating random integers. So integers are numbers without decimal place now. So we are generating a random integer between 1 and 100. So it's just one that you pick between 1 and 100 now. Then here you are now saying pick 10 numbers between 1 and 100. So you have this here. Do you all understand? Any questions so far?
No,
Any
sir.
questions so far?
No, sir.
Do you all agree with him that there is no question? Adebimpe Ojo, I can't hear you. Your voice is breaking. Maybe you should type whatever you have in the chat box. Okay.
Question.
No question from me. Okay. So moving on from there, then we have arrange. So arrange is to remember the way we did arrange at that time. Huh? So we have 25 numbers that we are arranging here. I mean, arrange 25 numbers yes, that we are arranging here. Then we have random integers here. We are generating 10 random integers between 0 and 50. So we run that. So arrange, you can see the arrange here. Then you can see the random integers generated. But then if I rerun this, it will generate another set of numbers. Not for array now. For the random integers, it generate a new numbers for the random integers. You can see the numbers are different. If I run it again, if I run it 2 million times, generate 2 million different set of numbers. You can see, then we can reshape. So we are reshaping this number to a 5 by 5 matrix. So that's how to reshape an array. So we use reshape to reshape an array. Then we can now start checking for different number positions in the array now. We're looking for the maximum number, the position of the maximum number now. So our maximum number is on position 3. So that's 0, 1, 2, 3. So it's in position 3. Then we have the minimum number. The minimum number is 0. And what's the position of the minimum number? So that's 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that. Then shape. So we can check for the shape of our array. You know, our array is 25 shape. So we can reshape it to 1 by 25. So this is 1 by 25 now. So we check for the shape to tell you 1 by 25. You reshape it to 25 by 1. You can see the way 25 by 1 looks. So we have 25 rows, 1 column. So that's how it looks. Then we have the shape to give you 25 by 1. Then we check for data type to give us integers. Do you all get it? Do we all get it?
Yes, sir. Yes, sir.
Okay. So moving on from there, we are going to indexing and selection. So indexing and selection now. In this lecture, we will discuss how some selection element or group of elements from an array. So here is we generated in, okay, let me just restart my kernel here. So here now we are calling for position 8 here. So if we call for position 8, what would this one give us? Using the knowledge of what's it called? Knowledge of list. What would this give us? Position 8. Position 8 to what would position 8 give us?
I think it will give us 8.
Any contrary opinion? Any contrary opinion? Any contrary opinion? Someone said it will give us 8. Any contrary opinion? I beg. If you agree with it 8, raise up your hand. If you agree it is 8, raise up your hand though. Some of us are just sitting out on the fence. Someone said 0 to 7. I'm not saying anything. Any other opinion? Any contrary opinion? No. Okay. In the absence of no, we are learning it. Okay, in the absence of no contrary opinion, so actually give us 8. You start counting from 0, 1, 2, 3, 4, 5, 6, 7, 8. But then, let me do but then. So what about this one? What would this one give us? Anybody, what would this one give us? Anyone? What would this one give us? Fire on it. What would this one give us now? I beg now. So none of you are just telling me.
I think it will give us the first 5 elements. I mean, first 6 elements also.
First 6 elements. Any other opinion? Any other opinion? Any other opinion? No. No other opinion. You agree with the first person that said the first 5 elements. I'm supposed to find everybody in this class. Everybody. Someone has saved you guys. But this person is always saying maybe. You're not saying you are not sure. When I said I'll find everybody. Okay, the person that said maybe 1 to 5 is correct, actually. I said 1 to 5, so it won't pick 0. Start from 0, 1, so pick from 1 to 5. But then it won't pick 5. You stop at 4. So we run this now. You can see stop at 4. Are we getting it? Do you understand the reason why it will stop at 4 and the reason why to print 1, 2, 3, 4?
No, sir.
You know the reason?
No.
Raise up your hand.
No, sir. No, sir. I don't know.
Okay. Do you guys remember when we're doing lists? Do you guys remember when we're doing lists? When we're doing lists, we said if we call an index of a range to give us from the beginning of the index to the end of the index, but then it will not pick the last one. So here now we said start from 1. So you know you start counting from 0. So you start from 1 here. Then it won't pick the last one. So you stop at 4 because 5 is the last one. Do you get it now?
Yes, sir.
So what about this one? What would this one give us? Samuel Joshua, he said it keeps you logging, it keeps logging off. Maybe you should go and join on YouTube. Then you can easily go back and see what we said in the past. What would this one give us? If you guys don't know this one, everybody on this call will pay. Don't let me see.
Is 0 to 4.
0 to 4. Okay, you are correct. All on your going. I would have just charged all of you biscuits. You send 1 carton of biscuits to my house.
Yeah, Joe.
Okay, let's go on. Then broadcasting. So broadcasting is just basically, what do we mean by broadcasting? It's just basically making values in an array equal to another value. So we are saying 0 to 5 here now equals 100. So every number between 0 and 5, that is 0, 1, 2, 3, 4. All these numbers will be equal to 100. So we run that. You can see 0 is 100, 1 is 100, 2 is 100, 3 is 100, 4 is 100. Are we getting it? Then here now, we now said 0 to 3 is 90. So what would this one give us? Zero to 3 is 90. What would that give us? God knows I go stitch up biscuit today. 0 to 3 is 90. What would it give us? I'm waiting for also. Yeah, that's correct. That's correct. Yeah. No, you are wrong. You are wrong. You are wrong. Check what you did and correct yourself. You made one mistake, one simple mistake. Yeah, you are correct now. This person is correct. So you know it will pick 0, 1. You are correct too. So it will pick the first 3 numbers. It won't pick 3 with it. So that's why I said the person is not correct and the other person is correct. Then the person became correct. So that's that. Yeah. So far, any question before we continue? So that I won't just be talking and talking and talking. Any question? You don't ask question, I'll ask question.
Can you hear me, please?
Yes.
Okay, I said no question before, but now I have a question.
Okay. Go
So
ahead with your question.
I'm not sure if you had explained this before, but please let me ask.
Okay.
This array of 0:5 you did equals to 100.
It's not.
Then
Don't call it 0:5. It's 0 to 5.
0 to 5, sorry. 0 to 5. Then you wrote it brought the result of 100 in 5 places, then 5 to 10. Is there a reason for giving us 5 to, or what's the condition, or what's the criteria for giving us 5 to 10 after giving us 100 in 5 places? I don't know if my question makes any sense.
Okay. The thing is, the whole array is 0 to 10.
Okay.
But then we now told it for position 0 to the position just before the 5th position. Convert all those numbers there to 100. So the array still has its own elements in front of it. It just is going to change those first 5 to 100. Then others still remain the same. Do you get it? Do you get it? Do you get it? Yawade. But the radio by you. The person that asked the question, do you get what I explained? I didn't even check the person's name. Then the person was talking. I believe the person got it already. So let's move on. So we have arrange. Okay, we've spoken about arrange. So here we are resetting back to the default. So that's 0 to 10. So that's 0 to 10. I mean, there's 0 to 10, yeah. So here now, we are now slicing. But something happened, what is going to happen here now? So we want to slice. You know what we mean by slice now? How many of us have taken slice bread before? I believe everybody must have taken slice bread before. So what we are doing to slice bread is what we want to do now. You want to slice. So we want to slice. So we want to slice position 0 to 6. So what will be inside this last slice of array? Anybody? Anybody? What will be inside the slice of array? Anybody? Slice of array. Or invest swimming class here. Slice of array. What would this one give us? Any ideas? Any ideas? Anybody? We are still learning it. No idea. Yawadi. Okay. How many of you remember when we're cutting lists? When we're slicing lists? It's the same thing. I still the same knowledge. Okay, okay, let me just do it here so you can see. So it will just cut out position 0 to 6, 0 to just before 6. So that's what it is giving us here. Do you get it now? Okay, moving on from there. They want to turn everything in. Okay, we want to convert everything in that slice of array now to 99. Notice dot dot without indicating anything in the beginning or at the end means the whole thing. So we converted everything to 99. But then we now check our array now. Our array is still 99. Everything inside in the position of 0 to 5 in our array has turned to 99. Why is that? The major reason why that is data is not copied. It's a view of the original array. This avoids memory problems. So in order to avoid replicating problems, Python actually, when you slice something like this, it just does something like a mirror image of the actual array. So it picks the parts that you give to it and shows it to you. That's what this thing does here. So just pick the mirror image and shows it to you. That's why you have all this. So the slice of array is still a member of this array, just that it's only taking this part and the others does not concern it. So whatever you do to this slice of array, you are doing it to this part of the actual array. Are we getting it? We don't get to talk now because this is where it starts getting technical.
Yes, yes.
Okay, I guess we are getting it like that. So if you want to actually copy, like, you know, when you write on your photocopy, it will not affect the original copy. Someone is saying I don't get it, please. Okay, let me try and explain another way again. Okay, you know, when you have, let's say you have 300, I mean, you have 10 oranges in your hand. But then, if you put the first 5 of those oranges in a bucket, why did it pick 5? It picked 5 because we did it here now. This is it here. Ọlọ́run Olúwakẹ́mi. This why it picked the first 5. I mean, the 0 to 5. And we said 0 to 6 now to stop at 5. Okay. Okay, she got it already. So moving from there now. So this one is like you have 10 oranges. You put the first 5 in a bucket. You now label the name of the bucket, slice of oranges. So if you peel the back of those oranges in that bucket, if you peel the back of the oranges in that bucket, you know, it will not affect. How do I feel now? It will affect the whole oranges. It will affect the first 5 oranges that you have, because the first 5 that you put in that bucket are still the oranges, are still part of the 10 oranges you have. So that's what is happening here. So this one is just like a label for the first 6 oranges in your list, in your array. So that's why you have this. So do you get it now? So when you do anything to those first 5, it affects the first 5 of the actual oranges because they are actually the oranges that you have. Do you get it now? Please, I need a response so I can move on. Okay, she got it. Okay, moving on from there. But then, if you now want to actually have, you can't do that one for orange actually, but you can do it for a paper. So you can actually do a photocopy of the actual original copy. So this is now where you do copy. So instead of array slice now do a copy. So that's where you now use copy. So you can copy the actual array, but whatever you now do to this new copy now, it does not affect the original copy. So that's like you went to the photocopy machine and photocopy your array. So you can see this is our array copy now. So whatever you do to this array copy will not affect the actual array. So you can go and try that on your own. So we go next to indexing a 2D array. So this is our 2D array. You can see our matrix here. So we call 1. What would this one give us? Anybody? What would this operation give us? Anybody? Anybody? What would this one give us? 1. How would it give you 1? Check it well. This is array 2D. This is what array 2D looks like. Then we are calling the first index. How would it give us? 10. 10. Any other opinion? Any other opinion? Any other opinion? So all of us agreed with Richard that it is 10. That's a lie. It is wrong. We said 1. So 1,0, you are wrong too. We said 1. But then remember, this array has 3 elements inside it. This is the first element inside the array. Second element inside the array. Third element inside the array. Let me explain why it's like that. Something like, let's imagine you and your mother. Your mother has 3 children. If you give birth to a child, does that affect the number of children your mother has? It will affect the number of grandchild she has, not the number of children she has. So here we have the first one, the second one, and the third one. But then inside this one, we have 3 elements. Inside this one, we have 3 elements. Inside this one, we have 3 elements. Do we get it? So when we call position 1, it will give us this. Is there anybody that does not get that? Okay, I assume everybody got it. So if I call this now, you can see it gave us 20, 25, 30. Then now, why not the first two? We start counting from 0 now. And we call position 1. Where do you get it now? Okay, you got it. Thank God. So now, when we now do this, what would this one give us? Anybody? What would this give us? Please don't fall my hand this time around. What would this one give us? I think everybody should get this one. No fall my hand. You go pay me if you fall my hand.
Okay, I think this
I think it
is 20.
20 exactly, to give us 20. God bless you. 20. Thank you very much. So here, so instead of having to draw 2 boxes here now, so we can just turn it into just 1 box. So that's 1,0. So if we run this now, it will still give us the same thing. Are we getting it? But then we can now start slicing our 2D array too. So we said from the beginning to 2 and from 1 to the end. So what would this one give us? Anybody? What would this one give us? Anybody? Anybody? What would it give us? Okay, you guys are still thinking. Let me just run it. Let me go back to this one. Can I have them in both ends on the screen? Okay, look at it now. We said beginning to 2. That's beginning to just before 2. So that's for the row. So beginning to just before 2. So that's these two rows like that. Then we said 1 to the end. So it will be from here to here like this. Oh, sorry. So it will be from here to the end. So it will just give you this, and this, and this. So that's what it's giving us here. Do we get it? If you don't get it, tell me now so that I can explain again. Do we get it? Oh, damn. Okay, I'll just continue. Then if you call 2 will just give you the last row. Then if you call 2, comma everything. So it's the same thing. So just give you the last row. So moving on from there, then we can create our zeros. So 10 by 10 zeros. Then we shape to 1. Shape 1. Array length. So we run this. So we are calling for the shape. If you actually call for the shape normally, let me just go up. If you call for array shape, give you 10 by 10, but then we said 1. So that's this. Do we get it? So that's this. So moving on from there. So now we now said for I in range array length, that is for I in range 10, array I equals I. Array 2D. So if you print out our array now. So what do you think this function will do? This for loop, what would it do? Let me give us like 1 minute to think about it. Anybody that can come up with an answer. If you can come up with an answer, I would really love it. Any ideas? Any ideas? Okay. If nobody is having any ideas here, I'll just okay, let me give you 30 more seconds. Just think about it. No answer is wrong. No ideas, no wala. Let's go on. So here now, what I'm basically saying is, see, for I in range array length. So for I in this array now, for I, so here we have this array. But you remember when I told you that this thing is, if you see it as 1. So it now say the first time it will see this one, second time it will see this one, the third time it will see this one, like that for the for loop, abi. So moving on from there now, we now say array 2di equals I. So I take the value of 0 the first time. So if you convert everything here to 0 the first time, then everything here to 1. You know, when it goes back, it will become 1. Then everything here to 2. Are you getting it? Then everything here to 3, because by the time it's going back, the number is increasing. So that's what we are saying here. Now, if we run this, you can see everything here became 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you get it? If you don't get it, let me explain again. Do we get it?
Yes, I explain again.
Okay, I should explain again.
Yes, sir.
Okay, let me just calm down and explain. See this our array here now. You know, when we look for the length the other time, it gave us, when we call this one, when we call 2, it gave us the last one here for this one. When we called 1, it gave us this. So start counting 0, 1, 2. So when we come back to this our own array here, it comes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put that in one hand. So now coming back to our for loop here now, we now said for I in range array length, and our array length is what? 10. So for I in 10, array 2di equals I. So the first time, this I takes value of 0. So the value of 0, then everything in that particular row now becomes 0. So everything here becomes 0. Then the next time it goes again, you know, loop is like circle. So when it's going again, it becomes 2. So I becomes 2. Then array 2di. So it becomes 1, sorry, instead of 2. It becomes 1. So you know, from 0 it becomes 1. So 2di, that's 2d1. So this is 1. So 1 equals 1. So everything in 1 now becomes 1. Remember when we did this thing the other time, when we're doing slicing the other time, you know, when we said everything here becomes 99. Let me go back to the beginning when we first did 100. Okay, here, when we say 0 to 5 is 100. So you know everything in that position tends to 100. So that's same thing that is happening here. Everything in this row becomes 1. Then again, it goes again. Our for loop goes again. It becomes 2. So here, everything here 2. That's position 2 is now equal to 2. So everything here becomes 2. Then position 3 becomes 3. Position 4 becomes 4. And like that, like that, like that. And that's how we got this. Do you get it now? Do you get it now?
I mean, I was thinking it's going to change it to letter I instead of
No, you can't change it to I. I is not a string. I think we quoted I here now. Change everything to I.
Okay. All
But
right.
then it's giving me error. You can convert float to I. You can convert string to float.
So, okay.
But then you are getting what I'm saying, Abby. So if I change this I now to 1, for example, change everything to 1. I change it to 2, change everything to 2. But then I change it to I. So I queries per row. So I change from 0 to 1 to 2 to 3 to 4 to 5. As it moves through this our for loop. That's why it's giving us 0, 1, 2, 3, 4 like that. Any other question?
This length of the class was 3.2.
Do we all get this? Do we all get this? So since you all get that, so here's another one now. This is where it gets very, very interesting. Let me explain this one now. I need all of you to get this. Confirm that you got this now. If you don't get this, talk now. If you don't get it, talk now. Because what I want to explain is built on this one. If you don't get it, talk now. Nobody's saying anything. So let's move on. Let's move on. So here now, for I in range array length, that's for I in range 10. Then for J in range array length, for J in range 10, array I comma J equals J. Let me come again. Let me come again. For I in range 10, for J in range 10, array I comma J equals J. If you remember when I was explaining the other time, array I comma J, so 0, 0 will be just this one. 0, 1 will be just this one. Have that at the back of your mind now. Then we now say equals J. So the first time it comes, J is equal to 0. So this place will be equal to 0. Then when it goes back, J becomes 1. So this place becomes 1. Then when it goes back, J becomes 2. This place becomes 2. And when it goes back, J becomes 3. Then this place becomes 3. Then when it goes back, J becomes 4. Then this place becomes 4. Are you getting it? Then when it now finishes this line, it now returns back to this one. Then this one becomes 1. So now come here. So J now starts from 0 again. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that till you get here. So that's what we are doing here. Anybody that does not get it, raise up your hand. I don't get it, raise up your hand. Okay, since everybody got it. Okay, moving on from there. Then we have array 2D. So what would this one give us? Anybody? Anybody? What would this one give us? So this one will just give us, you notice we have just everything we've been doing so far, we've been using one square bracket, but then we use two square brackets here. So this one will give us row 2, row 4, row 6, row 8. That's row 2. This is row 2 here. Row 4. Row 2 is the whole of this row. Then row 4 is the whole of this place. Then row 6 is the whole of this place. Then row 8 is the whole of this place. So we run this now. That's what it give us. Then if you say 6, 4, 2, 7, so to give us row 6, row 4, row 2, row 7. So you can see that. Then selection. So this is our range again. We are arranging our 1 to 10 again. So now we are now selecting values greater than 4. So basically what we did here, we return to us Boolean. So for everywhere that is greater than 4, it will give us 2. For everywhere that is less than or equal to 4, it will give us false. So you can see that now. So we now assign it to a Boolean array. So that's our Boolean array now. Then we can now apply that Boolean array on an actual array. So what this thing will do for us is, wherever it is false, don't print it out. Wherever it is true, print it out. So now, wherever it is true, that's 0, 1, 2, 3. So wherever it is true, that's this one will be printed out, this one will be printed out, this one will be printed out, this one will be printed out. So everything from here to here will be printed out. Because they are true. But then these ones are false. Then array less than 8. So for where it's less than 8 now. So from here to here is less than 8. So that's where it is true. So instead of having to break it down into 3 steps like this, you could just have done it in just 1 step. Do we get it? You don't get, raise up your hand. Okay, I believe we all get it. Then here is another one. So wherever it's greater than 2. So this one is giving us everything that is greater than 2 now. So the last part of NumPy that we are doing today. So thank God we will be able to finish NumPy today. So NumPy operations. I don't want to rush today, was what I've been giving breaks, but then nobody said they don't get anything. So that's why I'm moving on. So in case you don't get anything, let me know now. So I can slow down and explain that thing again. Before I come here, let me just go back to the last one we did. Is there anything you don't get? Anybody? Anything whatsoever? Nobody has any question? Okay, let's move on to the next one. NumPy operations. So let me just restart this scanner. So now NumPy operations. So we are importing NumPy and creating our array of 0 to 9. So we say array plus array. So give us 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, like that. Then array times array. Any ideas? Array times array. Please, someone should talk, I beg. I've been talking alone since morning. Array times array.
I'm just going to guess. So I'm guessing it would be each of them times their number, like 0 times 0, 2 times 2, 4 times 4. That's just my guess.
Exactly. Yeah, that's it. 0 times 0, 1 times 1, 2 times 2, 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, like that. Then array minus array. That one is obvious 0. Then array divided by array, same thing. But then it's giving us this red sign because 0 divided by, anything divided by 0 is infinity, not a number. Oh, thank you to Oluwakemi. Thank you very much for your response on the chat this thing. Then 1 divided by array. So will give us 1 roll in here because the first one will give us infinity. So that's that. Then array raised to power 3. Anybody that can give me an idea of what this one will give us? Anybody? Someone should talk, please.
Each raised to power 3.
Exactly. Each raised to power 3. That's that. Then universal array function. So we have square root, this SQRT for square root. So square root of each of them. Then exponent, that's e raised to power. Let me of us know what my exponent. You don't know what exponent means? Raise up your hand now. Exponent. You don't know what exponent means? Raise up your hand. Okay, everybody knows what exponent means, so I am safe. Then we have maximum. We know max already. We used it before. Then sign. That's SOHCAHTOA, our normal sign in mathematics. Then logarithm. But this one is logarithm to base e. That's what we call lane. That's logarithm to base e. So that's that on everything we have for today's class. Any questions so far? Any questions, suggestion, submission, addition, subtraction? Because we've actually finished everything we have in stock for today's class. Any questions? Someone say something, I beg.
None for now, but I maybe after watching the YouTube video again, I might come up with questions because I got lost at some point. But then after watching the YouTube video, I should be able to come up with something.
Okay. But if you know the points where you got lost, you can quickly explain them now so that you won't have to go back again.
Please, if I say I want to go back, questions will be coming after questions.
I can't hear you. Your voice is breaking. Oh, Jesus. Your voice is breaking. I can't hear you. Oh, you're right.
Hello.
Hey, I can hear you now.
I said if I say I should take us back to where I got lost, it might be a lot, but let me just go through the YouTube videos, the YouTube video rather. Then all my questions that I have, I'm just going to send them to your DM if that is fine by you, because I didn't get lost at just one point. I mean, a lot of places. Thank you very much.
And someone is saying, what's beside the value D type? D type, where is that? I can't see it too. Is anybody seeing D type anywhere? I don't know where the D type is. But D type is actually data type. But then I can't find it in this notebook. Maybe in the previous notebooks, yeah. On the result of array raised to power 3. Okay, D type integer raised to power integer 32. Yes, data type, that is each of data inside this array. Data type it has. You know, array can only take numbers, float and integers. So here is an integer. Everything here is still an integer. That's why it's telling you the type integer. Do you get it? And that's because we performed an operation on the numbers in here. It does not give you anything here because we automatically know this one will be float. But then this one is raised to power 3. So it's still giving us integer. That's why it's writing integer here. So the data type is integer 32 bits. That's what it's saying here. Do you get it? I just told you why it's not showing the front of the other ones too. That's because it is easy for us to generalize because our data type is integer here. So this one is integer, integer, integer. Anytime we divide, it automatically floats. This one is float and it's not telling us anything. But then raised to power 3 is giving us integer 32 bits. I didn't even say raised to power 0.5, for example, now 0.5, which will give us, you see, it's not giving us float again. It's not showing us float because this one we are expecting it to be float normally, but then we change it back to raised to power 3. It give us integer because most of the time it's supposed to give us float, but then so it's giving us integer actually. So that's why it's mentioning, okay, the data type is still integer, it has not changed to float. So she got it already like that. Okay. So I guess it's a good place to stop today's class. Since there's no question, there's no addition, there's no subtraction. So I think we'll end today's class. But I beg, we are still trying to raise funds for the class. So if you know any way we can raise funds, and with your assistance to Abeg. God bless everybody. So see you guys in the next class. See you, Anjuma.
Wait, okay. Are we not having? Okay, there's no exercise.
Oh, there's assignment. There's assignment. I've already pushed it to our GitHub, to my GitHub repo. So I'll comment the link to it to the video on YouTube. So you can always just go there and pick up the assignment and do.
All right. Thank you very much.
Welcome. Bye-bye.
Bye.